So we have been given the problem to draw the bending moment diagram of the given statically indeterminate frame. So in the figure, we can see that we have point loads of 120 kilonewton and 20 kilonewtons at the span AB and BD respectively. Also, we have a continuous load of 20 kilonewton per meter between the span BC. So the first step. So we find the fixed end moments for the individual span. So for AB, I have set the kinematic indeterminacy 0 at point B by providing a support. Now, to find the fixed end moments for AB, so apply the formula MFAB equal to force times the distance from point A. The force is 120 kilonewtons. The distance from A is 2 meters. Multiply by the square of the distance from the other end, which is 4 meters square, divided by the length. So the length of the span is 6 meters. So the 6 square. It turns out the value equals minus 106.667 kilonewtons meter. Similarly, we can find the fixed end moments from from the side B towards A as MBAF. So the force is same, which is 120 kilonewtons. Since the direction is reverse, so here we apply the positive sign into the distance from B, which is 4 meters. Here I have written 4 meters. Multiply by the distance from A square, so 2 square, divided by the length square. Similarly, we can get the fixed end moments of all the span of the frame. So here I have got the fixed end moments of the member BC and BD. Now coming to second step, we can find the moment of the individual span in terms of its corresponding fixed end moments and the slope at endpoints through slope deflection equation. So we can write the slope deflection equation for AB by writing MAB equal to its corresponding fixed end moment, which is MFAB, plus 2 times the flexure rigidity, which is E times 2I divided by the length, which is 6 meters. And this is 2 theta A plus theta B is the slope at the endpoints. Theta A is the actual slope and theta B is the induced slope. So uh, since at point A the endpoint is fixed, therefore there is no angular displacement. Therefore theta A equal to 0. So we can back substitute the values and get MAB in terms of theta B and form the equation 1. Similarly, we can write for MBA through the slope deflection equation and forms equation 2. Writing down for all the members, we can get 6 equation. We can see that here I have written MCB equal to 0. From the figure, we can see that since this end and this end is simply supported, so the moments here turns out to be 0. Finally, we get 6 equations but 7 unknowns. So we can form the 7th equation from third step, which is to find equilibrium of B. In the figure, we can see that since there is no external moment, so we can write the equilibrium equation of B as MBA plus MBC plus MBD equal to 0. So all the equations, all the moment equations at B corresponds to 0. So we back substitute the values of MBA, MBC and MBD equal to 0 and we get the 7th equation. Now from all the 7 equations, we can simultaneously solve it and get the value of theta B, theta C and theta D. Now we can also write the corresponding moments of the span by substituting the values of the slopes. So in the next step, we can find the shear force of the individual sections. So here I have taken the section AB and written down the force balance equation. So Ra plus Rb1 equal to 120 kilonewtons. Also, I have written the moment equilibrium equation, and from these two equations, I can get the value of shear force. Similarly, we can do the same step to get all the shear forces of the individual spans. Now, getting the value of shear force and the moment, we can draw easily the bending moment diagram of all the section. So for the section AB, this is the bending moment diagram. For section BC, this is the bending moment diagram. And for section BD, this is the bending moment diagram.